Before I begin, can anyone volunteer? Wow, that is loud. Can we turn it down just a little bit? Would anyone volunteer to just write down questions? Usually I like to do these very open-ended and just get a bunch of questions, and then we can republish them later, and we'll publish it to the KubeFlow Discuss list, and people can talk about it. You mind? Thank you. Always stepping up, Josh. Did everyone, people are coming in late, did everyone get the room switch? Apparently this is not financial services. I think that's D4 now? C1, sorry, C1, thank you. Okay, well, let's get started. This is KubeFlow Birds of a Feather. Thank you all for coming. I like to actually not have any agenda whatsoever here. The idea is a birds of a feather. We're just supposed to get together and talk about what issues we're having or questions we have. This is actually a merging of two different birds of a feather that we're trying to get together right now. The KubeFlow side, where I'm happy to answer questions, but then also we're doing a cross-project effort around metadata and seeing what we can do to bring KubeFlow metadata to other cross-platforms. And we can answer questions about that as well. The metadata folks, let's make sure to loop up afterward, and we can talk about what we should do. But let's start it up. So, who's using KubeFlow? Who has questions, comments, points of view, things you'd like to bring up? Who's using it in production? Good experiences? What do you got? Yep.
Okay, I like to mention KubeFlow.
Okay. Yeah.
In DevOps, there will be DataOps.
Yes.
Data scientists in the future will have the knowledge about infrastructure, serving, modeling, etc.
Yep.
But KubeFlow is kind of, I don't use it in production, but I would like to know if... Start again?
No. Yeah, okay. I'll give you a summary to everyone. Go ahead.
Okay. My idea is what is in the roadmap for KubeFlow in the sense of managing these new challenges that are architectural and on process and related to the data science. I'm more on ops guy.
Yep.
But I'd like to have the knowledge to how this future architecture will be.
Absolutely.
Storage, how to deploy, for example. There's a part where you can, with the Jupyter Notebook, create a pipeline. It's not fully automatic. Mm-hmm. There's not a visual tool to create that are, for example, in Databricks or in the production-ready solution for the data scientist. So what is the plan? What is the future? What do you imagine?
So the future comes tomorrow. I strongly suggest, the question was relative to your KubeFlow and KubeFlow pipelines, how do you think about moving these things to production? And I'm going to add on top of that, without forcing the data scientists to think through Kubernetes or operations or things like that. Let me recommend, very selfishly, two talks that we have tomorrow. We have a KubeFlow 1.0 talk, towards 1.0, not announcing 1.0, we're getting towards 1.0. Tomorrow, where Jeremy, who is sitting 2 seats away from you, will be demonstrating some really cool tech that is shipping today in KubeFlow called fairing. And the idea behind fairing is it abstracts, for a data scientist, all of the elements you just described. It lets you take a notebook, strip it of the things that are uninteresting to you, package it in such a way, Docker container and so on, with the correct endpoints and so on, and then it deploys in whatever form you need, either locally, to a distributed cluster, maybe to the cloud, doesn't matter. But it will give you, a data scientist, the ability to do all of those steps without having to understand Kubernetes at all. Fairing is the bridge behind the scenes that takes care of it. So, in just a few lines of Python code, they're able to do that. The second talk, which will be at 2:55, is one where I will be demoing ML Ops, as we call it, which is machine learning operations derived from GitOps. and we will be demoing how to drive a KubeFlow pipeline from a Git check-in. So you'll do your Git check-in of your model code. That will parse it through, make sure it's appropriate, the notebook is correct, and everything is correct. And then it will kick off a KubeFlow pipeline right there that does your training and potentially even moves it out to production. But then potentially, and the demo we have tomorrow, just to show what we see as a very common scenario, it hands that trained model off to an inference endpoint. So instead of self-hosting your KubeFlow, you host it using something like Google Cloud Machine Learning Engine, Azure Machine Learning Engine, and so on, which is a very common scenario because you don't want to necessarily host on the same cluster you're doing your training on. Sorry? And we also have a Thursday session from Iguazio. You should check out their stuff as well. They're doing.
And I'm also showing.
Oh, okay.
And
yes,
I'm showing the serverless serve pipeline.
Right. And thank you very much, Yaron. Even extending that further is to go into serverless, using the exact same abstractions, but with serverless. So rest assured, we have heard your concerns loud and clear. We want to get there very quickly, but we're trying to be thoughtful about it and do this in a very production-ready way.
Hi, Martin. I have a question regarding multi-tenancy. I want to ask that there are lots of different technologies to do it. At the moment in Kubernetes, we have namespaces, network policies, OPA, SPIF, and so on, and so on, and so on. Then I know that KubeFlow consists of several tools. There we have what Jupyter Hub is using or not using, honestly. So when do you think will be the time that or how will you find a good way to have multi-tenancy and all the role modeling?
So that is probably, if abstracting data scientists from Kubernetes was the #1 feature request, multi-tenancy, multi-user is the #2 feature request. Jeremy's about to answer your question in far greater detail, but we have heard that one as very, very loud and clear as well. Jeremy, do you want to talk about anything in specific?
Yeah, I mean, the plan is to leverage the functionality that's landing in Kubernetes to try to deliver the multi-user story. So obviously that story is still evolving in Kubernetes, so we're not going to be able to get very far ahead of Kubernetes. But mostly what we're looking at doing is using things like Istio to isolate network traffic so that you can't access somebody else's notebook if you shouldn't. And then using namespaces to isolate teams and users in RBAC roles, right? So you're going to be sort of limited by how well you trust those mechanisms, and as those mechanisms become more secure, you'll be able to do stronger tenancy isolation than you can now. But that's our current thinking.
Yeah.
Break things to namespace. It's still not fully baked, but you can actually you're not forced to deploy in KubeFlow namespace. So you can actually create multiple KubeFlows in different namespaces.
Right. So the summary is, again, we've heard it loud and clear. More than anything, we'd love your guidance. There's, in fact, I think even a multi-user SIG. Am I wrong about that? Don't we have a multi-user SIG, or is that the on-prem SIG that keeps talking about multi-user?
We don't have one in KubeFlow. There is a multi-user SIG. I'm sorry, a multi-user, multi-tenant SIG, I believe, in Kubernetes.
Yeah. So that's it. But regardless, we have heard it. At the end of the day, again, we want this to be, fully abstracted for a data scientist. They just go to an interface, they click a button, and they are provisioned within whatever their namespace or their scope is, a Jupyter notebook that can operate. So that is absolutely our goal. It's just a matter of when, and we can get to when faster if we have your feedback. Yep.
Hello. In reality, I have a lot of questions.
That's what we're here for.
Some problems. Standardization of serving, because it seems a battle between TensorFlow serving and Seldom, for example.
Yeah.
Is there a way of standardization? First question. Another one. Okay, you can answer this one if you. for starting.
Sorry, so serialization for serving?
No, sorry, serving, just serving.
Yeah.
It's a protocol or standard or something like an API for the future.
You're speaking my language. So one of the biggest things we're doing around metadata right now is there's a cross-group collaboration right now who is working on exactly what you're describing. It's called KF Serving. It's an open discussion, and those that are interested in working together. This is people like Selden. We have people from Google. We have people from Azure who are working in
SIG.
Sorry?
It's a special interest group.
It's not an official SIG right now because we don't have a SIG like procedure, but certainly it's not being done in secret either. It's just like conversations. The specifics is ideally there will be a way to explicitly through a standard set of APIs provision a model to be served in any of a number of serving formats. And you should jump on board, and I know the team is working really hard to get there. But yes, the long and the short of it is, yes, they are working towards a standard API around that. I know you had the mic. I don't know. Go ahead.
My question is, MLflow, for example, have made some works on standardization. Why there is any? I didn't see an integration with what do MLflow, for example.
Sorry, that was super echoey. You said MLflow has what?
Have some stuff done on standardization of serving, for example.
MLflow has a standardization of serving?
And for example, there is experiment tracking like does KubeFlow Pipeline. Why it wasn't just integrated inside KubeFlow?
So I know a lot about MLflow. MLflow doesn't standardize. What they do is they abstract away the actual interface. And so when they do an MLflow deployment, they're doing the hard work to translate between what happens in MLflow to the ultimate serving stack. Unfortunately, that means that the provider of the serving stack doesn't, a lot of their goodness doesn't come through, right? Because there's no standard way for them to extend it or anything like that. We would love MLflow's collaboration. They don't, they haven't seemed to do that yet. But we think with what we're doing with KF Serving, we're going to give you something that actually works across a number of different serving stacks and is supported, most importantly, supported by the vendors who will be doing the serving rather than supported by the framework. Again, and we've talked with MLflow many times. It's not that they're just moving very quickly and they're trying to figure it out. And from my understanding, they're looking at doing KubeFlow integrations. But they to date haven't been interested in working with other open source projects. So what Yaron just said, for those that didn't hear, they're working on a standard for experiment tracking across a number of different frameworks, and he'll be demoing that.
Hi. Another question regarding the installation process. KubeFlow takes the step to have the installer as a separate binary and hides the installation process like Spinnaker does. Is this the future of Kubernetes, so that every application ships its own installer?
I think installation, look, we've heard that installation is not easy and we would like to get much, much better at it. The reality is we moved away. We initially were a bash script and then we moved to this binary. I think we would love to consume whatever is the cloud native, most flexible way to do it at the end of the day. But we think that the Go binary that the team has worked on is probably the best that we've found so far. That said, I suspect in an order of weeks there will be a sample Helm chart for installation out there and other things like that. So we're open to whatever the team would like. I think that what you're really seeing is a number of layers that for a long time were merged together, and we're really trying to tease them apart. So you say like, well, here's me provisioning the hardware or the IaaS layer. Here's me provisioning the services on the overall framework, and here's me provisioning cloud-specific extensions. And we're trying to tease those apart so that they can be loosely coupled. But Jeremy, would you like to?
Yeah, I mean, I think David's exactly right. KF Cuddle, it's basically, I would say it's like syntactic sugar, trying to address a usability issue that we saw. So ideally, we would just be using native installation tools, whether that's Helm or Customize or something else. But what we saw was that if you just write down the commands the user would have to do to actually do it, it was just too many. And so we, as David said, we started providing a bash script, and then for various reasons, we decided to rewrite that in Go. But yeah, I'd love to get rid of that if we could, but it's a question of what's the right solution.
Who else?
Hi, David. There's a hot topic about the GitOps. I don't know if you guys think about how the KubeFlow or the metadata discovery or the Spec going to evolve with the Git.
I think you came late. We actually have a topic tomorrow about MLOps, but I'm going to steal the second point of what you said and talk about that for a moment. One of the things we want to leverage here is really think about metadata, right? And the KubeFlow team has done a great job integrating the MLMD from TensorFlow Extended, which is the standard library for reading and writing metadata and things like that. That's great, but that still leaves our job, or a number of different people's jobs, to define what the metadata is, right? Think of MLMD as the gRPC, the simple way to read and write metadata, but it's up to us to define specs. And in the KubeFlow metadata repo, there's already a great start there, and you should all jump in and think about like what looks good there. Look, candidly speaking, I think that metadata is a cross-industry issue. And if it is just something that exists inside of KubeFlow, I think we're not going to get as much adoption of these specs as we would like. I think, and again, my proposal that is coming soon will be to figure out a way for the ML Commons effort, which is a very broad industry effort with people like Google and Cisco and Dell and Stanford and all these folks coming together to establish some standards around ML specification schema. Because if you do that, then now rewriting or writing portable ML pipelines becomes very, very powerful, right? Imagine, let's say you're a Google Cloud customer and you're using KubeFlow, but then instead at the last step you want to use Cloud Machine Learning Engine to do your hosting. Today that would be hard because you would have to have some translation layer between how to serve in KubeFlow and how to serve using Cloud Machine Learning Engine. If the metadata between those steps were standard, then doing that translation would be much, much easier. And the steps that I'm talking about schematizing that I think are really powerful are, for example, when you finish your data processing job, you have a schema that describes what you did to your data processing. Literally, what the source data was, what the transformation was, what the statistics of that are. After you finish training your model, perhaps you output standard statistics around that, what framework you use, so on, version, so on and so forth. When you want to package your model for production, you might want to output profiling information. This needs GPU, this needs CPU, so on and so forth. That's another bit of metadata. And then obviously how to serve this in production. How many regions, how many zones, what kind of machines, so on and so forth.
There is another point. There are two levels.
Yeah.
schemas would be, for example, for training jobs, for data preparation jobs, etc. And what I'm currently focused on, and I'll show a few slides in a minute, is how do we create sort of this common layer, the first substrate, that on top of it will build those schemas.
Yeah. By the way, does everyone, I am not the only host of this. Yaron is also a host of our Birds of a Feather. Does everyone know Yaron? First off, do you know who I am? I'm a guy. I helped start KubeFlow. Yaron, you want to introduce yourself?
Good, and I'll, if you sort of finish, I can show the slides and then we'll...
You're talking to the microphone, they can't hear you.
Okay, so hi, I'm Yaron. I'm Iguazio CTO. Iguazio is sort of doing machine learning platforms for a living. What we're trying to do, we're also adopting KubeFlow in many of our solutions, but we've examined all the different solutions in the market, including deep learning of MLflow and other solutions, and we're trying to sort of create a common denominator where we can work with the cloud provider tools, you know, Azure AI or SageMaker or whatever, our platform, etc. So one of the themes for this session that we want to apply is present a way to deal with metadata. We also did some GitHub issues around proposal, and get some consensus from all the sort of vendors as well as users on what this needs to look like. I think it's very critical for us to agree on that layer. And once we agree on that layer, then David has a lot of vision around building those sort of what I call schemas, so domain-specific metadata mechanism.
And so, all right. As a summary, though, I do want to say. I feel like I'm in an airport. But the net of your point is absolutely correct. First off, I cannot overstate that KubeFlow is the first public project who is set even the idea towards metadata. So they are setting the bar right now, and I want to have it plug in. All I want to do is take it slightly further than KubeFlow so that other folks can plug in as well, because we see this, this need all over the place. Do you want to do? Sorry, that's my fault. Well, why don't we do a question while we're doing setup? Anyone else have a question? Yeah, go ahead. What about TensorFlow? Oh, KSNet. Yes, KSNet's dead. Move on. So we are a 0.5 project. We knew that we would make decisions in part of being before 1.0 that may not have been the right ones. KSNet is on me as much as anyone. We needed a framework to allow for portability, one that could be parameterized based on the environment that you ran on. We look at KSNet, it looked like a good mapping. Unfortunately, with it being deprecated, it's just not a good fit for us anymore. So we're moving everything to Kustomize, which is native to Kubernetes. So we feel much more confident that it's going to be a long-term bet for us. And it is absolutely part of our P0, but ideally everyone in the community, to help us translate KSNet artifacts into customized artifacts. And it should be fairly straightforward to do so. But we're going to build tooling and testing, and it's on us to make sure that translation happens quickly and with as few bumps as possible. Do you want to walk through your?
Sure. So I'll take a few minutes of your time.
Just a little bit more to your mouth. Do you want to use this?
Hello?
There you go.
Good. I'll take a few minutes of your time to talk about the metadata and experiment tracking problem and how we think we should go about it. So everyone already familiar with the data science pipeline? I think just one thing that people tend to forget, that it's not always batch ETL. We also have streaming and dynamic fetching of data and all that. And every step essentially have some inputs that consist of code and some other things, and have some outputs that consist of data and potentially notifications and metadata. When you move into the sort of the inferencing or serving or more the real time, there's also sort of a different type of pipeline. Here, experiment tracking is not a one-time thing. Like when you do a batch, You run something, you have a result. When you run something in inferencing, it actually could be a real-time series data that keeps on pumping. So we need to think about those things as well when we create a common execution or a metadata model. By the way, in my session on Thursday, we'll demonstrate some of those things. So there are many monitoring tools. I just listed a few of those. That's an Uber tool, that's MLflow, that's ModelDB, and I could list another 5 of those here. Each one is trying to do model experiment tracking, okay? And you can see the commonality around them. They start trying to record some metadata about the experiment, some parameters, and some output values, okay? So that's the typical experiment tracking tools. There are other tools that sort of from a different neighborhood, somewhat related, somewhat not related, that deal with data versioning. So in KubeFlow Pipeline, we do have a mechanism for data versioning. Has some challenges, but it's there. But there are other tools like DVC, if you've looked into that, Psychoderm, Databricks has Delta. I assume there are a few other tools in that space as well. One of the challenges, by the way, that you see, these are different types of tools. One tracks the experiment, the outputs, one tracks the sort of the inputs and data related. We want one mechanism to track both. The other thing that I'm really hands-on guy. I like to code and I do machine learning and all that. So I'm feeling the pain when it comes to dealing with secrets. Moving environment variables around. And in my Jupyter notebook, I don't have, or in my IDE, I don't have secrets. So how do we mess with all those, sort of still maintain security? At least we remove the Minio123 password from the serving layer of KubeFlow. Now it's environment variable, but still there is an issue that if you have a serving server and I have different users accessing the same serving server, then all of them have the same credentials. So security-wise, it's a challenge. Other things like it's runtime specific. When I need to run an experiment in my notebook, I typically do Shift-Enter. I don't have any wrapper that sort of wraps and injects my different parameters. When I'm running a CLI, like MLflow, you can do command line. When I'm running it in a container, I need a way to pass those parameters to the container. And if it's in a workflow, I need another way to pass it across steps. And if it's a serverless function, it's even per invocation. So for every runtime, we have different ways of passing metadata and passing data around. And it's also platform specific, whether it's Google Cloud or Azure Cloud or Kubernetes or KubeFlow or Databricks. It will be different ways of doing that. So what we want to do is provide a common way of managing metadata, data, and results. So it's not just focus on experiment tracking. I think we need a holistic approach to all of those, and I'll show you a prototype I did over the weekend. So it's not productized, just to show you how you can go about that. Okay, but what we want is to maintain execution, metadata inputs and outputs. So the focus is on an execution. What is an execution? Execution can be something that does training, could also be a function that does inferencing. So we don't need to think just, one of the things I think I told Jeremy is like we say experiments in pipeline. No one said that an experiment could not be a CI/CD pipeline. I can essentially create a workflow that's all its work in life is not to run experiments, it's essentially to drive a CI/CD pipeline exactly with the same tools. So we may even need to consider changing experiments to some other more generic term. So we want to do it in a runtime independent way and platform independent way. And the key focus is how do we abstract that to the user, to those data scientists that want to write code. And also, we potentially, every vendor may want to build his own visualization tools. Maybe the cloud guys want to store it in their, BigQuery or DynamoDB or whatever. So we don't necessarily want to lock, just like in MLflow, there's an abstraction of the way things are stored. So we want to keep some abstraction. So what do we mean when we say tracking those runs? So first thing we need is metadata tracking. So every run has its unique ID, but it usually has some name of a task or a job. It usually falls under some project or a workflow, sort of some parent above it. It comes from some source. This source may came from a Git and has some hash key. or some tag associated with it. And potentially we can go on and on with metadata through labeling and annotations like every Kubernetes element. Obviously there is an owner associated and maybe group of owner, etc. So that's metadata. Then we have inputs. Inputs, we can define three types or four types of inputs. One is parameters. The second one is secrets, because mostly everything we would need to do, especially when we're starting to think more real production, we need to have credentials to access different resources. So we need a way to inject, a secure way to inject secrets in a sort of platform-independent way, and not just secrets on Kubernetes. Maybe secrets on Kubernetes, but when I'm on my ID, I don't have a Kubernetes cluster. And then we need to think about artifacts. It could be two types of artifacts. Could be sort of more blob and files, and could be also, data sets or data frames. And then we need to think about outputs. Outputs, again, like three categories of outputs. I think we're confusing the term when we say matrix in KubeFlow. It's actually what I call values or outputs. Values are singular values. This is the result of the experiment. Matrix is more of an array or a time series, and that's essentially the same definition in MLflow. In MLflow, matrix means an array. And if you're running inferencing, a matrix may be endless, because essentially it keeps on pumping data every run, every injection. So it could be an ongoing time series. And then we also have artifacts, which could be, again, file, objects, and tables. And there's also some things like status, when did it start, when did it end, what's the current state of this execution, etc. So I think in general, those are the type of thing, maybe we could add more. And as a community, we want to do the work in sort of a Git, and everyone will need to find a home for that. But once we do, then we need to start standardizing what we want as part of metadata and context. And then using that semantic, what we want to do is allow a very simplistic approach for data scientists to go and consume and use that context. And then we'll figure out how we implement that in Go and Python and whatever. But the general idea, we want to start this execution with getting some parameters. Okay, so now the nice thing is that I want to supply some defaults, because if I'm running in my notebook, and there's no runtime that injects parameters, I want this to just run and just edit and go delete and change and run, etc. The next thing I want to do is, the thing that you want to do is establish a context. Who generates the context? We'll talk about it in a minute. But when I'm running something, I want a context, and this context preserves all the state of inputs, outputs, and metadata. So again, I could have parameters. I could override parameters from external context. I may want to have access to metadata, like in this case, the name, UID. And you'll see that the parameters, once I'll print them, they're not necessarily the ones that I use as defaults, because maybe the runtime injected new parameters because I want to run this exactly the same execution, just in different parameters. We want to have simple access to secrets. So again, there could be an interface for getting secrets and using them. We may pipeline those secrets into resources like storage, and I'll show that in a minute. And then we want to access artifacts. One of the issues with accessing artifacts is that artifacts could be local file system. Then there's one way of accessing them. And if it's object store, it's a totally different set of APIs. So maybe we could even here come with an abstraction of saying, you know what, I'm doing a get, or saying if you want to row data, just give me the path, I'll figure it out. But if it's actual data and I want to change for read locally from a file and remote from an object, maybe I want some interface to wrap it and let something else figure out all those things, secrets, how to do parallel get from S3, etc. And then again, we have outputs, which could be logging of values, logging of matrix, and logging of artifacts. So a simple use of that mechanism would be to wrap it in a function that I can just execute, and then just generate an object of a context and run it. Okay, so that's one example. But we could do things that are slightly more sophisticated. Again, I did it as a weekend job, so. But again, the same code that we discussed, it's just with slightly more explanation. And what I want to do is I can run exactly the same thing from my notebook. and just running, this is this function. I won't show you the secrets because that's my credentials to S3. And I can run the same thing with now just injecting a context through command line. So, for example, I'm going to run it. I'm changing the parameter, which used to be, remember it was 1, and I'm essentially changing it to 3. And when I'm running this script, you see that it's essentially auto-generating the UUID. It changed the parameter because I injected the parameter. It also changed the output. And it's reading the file from a local file called, whatever was there, this infile.txt, okay? So this guy is a local file. I also have my S3 bucket, and there I put a different file called infile, and you could guess that it's not saying it's a local file. And then I can run exactly the same thing and just say, you know what, this time I want to override an artifact. Infile.txt is not really infile.txt. It's like S3 / my bucket, whatever. And then what I'm getting is the result of the file is now my S3 object. And again, I can override parameters. And you could see that things are, all the results are sort of a metadata that could be written to a database. Didn't manage to write it to a database in a couple of days. But again, that's a general idea. So this way, we can develop using a very common semantic, which is very abstract, for every data scientist could get it. It will actually simplify all the environment variable meshing around. And all those things that I injected could be more automated. Like when I'm running in a workflow, this injection process could be something that pipelines inject into the function. And maybe the secrets, when I'm running on Kubernetes, will be gathered from Kubernetes secrets, whether they're manifested through environment variables or through a file. By the way, the reason that I didn't need to say anything about the secrets to get to my S3 bucket, because the secrets file essentially has all the secrets that are passed across all those things that need access to secrets. But this just demonstrates a simplistic way that we can all, as a group, try and again, not pushing any of my agendas, but I'm saying if we agree together that this is the standard that we want to follow, then it will make the life easier for building the next layer in the chain.
How long? Is that it?
Okay. Any questions, comments?
Oh, all right. I guess we're out of time.
So before they kick us out, do you think it's a good, valid idea?
So we are out of time. I guess we're being removed from the room, like now? Oh, 4:30. All right. Well, we'll wait until someone opens the door. All right? That's what we'll do. Or you can leave.
So is it something that people want to pursue? Is it something?
So if you'd like to talk metadata, let's make sure to go outside. Exactly to Yaron's point, though, just doing something like this, where you have a structure for tying multiple pieces of metadata together through like a context or a run, having standards for inputs and outputs for given steps of your metadata will unlock so many important things. And really, just the presence of those will help unlock, metadata and GitOps and MLOps and things like that. And like I said, I think that KubeFlow has done a phenomenal job being the first person to first organization to think about this generally, but I think it would be great if we could expand it out to help other organizations adopt similar ideas. All right, they still don't have anyone, so yes, go ahead. This is a proposal for a project that Yaron is working to. There is no...
We're talking about it also in the list, but the idea is to get more people around it.
Right.
We can go and implement the skeleton and hopefully work with everyone else
to be incredibly clear in all of these capacities, the people who show up with code and passion and real world use cases, no boiling the ocean. If you solve a real world use case like the folks collaborating on the standard for KF serving are doing, that's going to win. No, it's not win or lose. It's just that's going to have the most momentum. So if you're passionate about this and have the time and energy and coding and so on and so forth, guess what? That's what people are going to gravitate to.
But I can publish the Git repo for this code later.
Yes, so this is absolutely not official, but it's also not official because he's doing this and the code is there.
Okay.
Yeah. To visualize the metadata? No, and not to my knowledge. I mean, obviously, KubeFlow Pipelines has a great visualization built in when you go to the dashboard. I don't know how decoupled that is. It's just not my area. Like whether or not you could theoretically visualize that in some other capacity. I can't imagine why not. It's probably just stored in MLMB.
This is, by the way, KubeFlow Pipeline.
But regardless, yeah, if you haven't seen it, regardless, I think visualization, standard libraries, inputs, outputs for visualizing, I think would be really powerful. And if we were able to do that, then ModelDB could use it, and MLflow could use it, and KubeFlow Pipelines could ideally use it, and things like that. So if someone wants to show up with that, then that's great too. Yes. So there are two things, and I don't want to blur them. KubeFlow has its own repo called KubeFlow Metadata with issues and discussions and things like that. There is, in addition to that, an effort right now called MLSpec. That's MLSpec-discuss. And that is a second effort that's ongoing right now. My dream is that the two are coincident, but KubeFlow has to move faster right now, and MLSpec is waiting for ML Commons to land before we make that official. So if I could wave a magic wand, KubeFlow would continue on its path, and we all the people who wanted to work on MLSpec worked on KubeFlow metadata and made sure that it looked good and was portable and things like that. And then when it came time to graduate, we moved it into ML Commons, and then everyone's happy. But we'll see. I'm sure there will be, oh, we want to use a UUID. No, I want to use this. I'm sure that will happen, and we'll have to figure that out.
Yeah, but I think there is enough common practice today in the industry because I've sort of went through all those frameworks.
Yeah.
And everyone copied from the other guy. So we essentially we just need to sort of aggregate the copy process.
But and I'm going to credit Jeremy for saying this. Like he did it at the Contributor Summit. If there is not a specific use case for it, it will not be successful. If we are just defining a schema and nobody adopts it, it doesn't matter. So there's already a great one for serving. My proposal is that we collaborate on one for model packaging or experiment tracking, both of which are big needs right now, right? If we figured out a schema for model packaging, for example, that would be really powerful because then that would allow for provisioning underlying infrastructure based on the model package. Oh, I see this is a TensorFlow model and it needs GPU and this much RAM. I know how to provision for that.
Yeah, by the way, back to my point about experiments could actually
Fairing is great, but if Fairing would need an interactive mode to something like a SAS, right? And so that communication would have to occur over some form of standard schematized metadata, I propose. And so that's all I'm saying. I'm not saying I don't want to write the libraries for this. What I really want is just standard schemas.
Yeah, by the way, back to my point about this experiments and runs is, sometimes it's overloaded terms. Just look at the pipeline I'm showing here. It's not an experiment. Okay, it has an experiment which is only a portion of it, but after doing the experiment, it's actually doing deployment, and after the deployment, it's actually running a full test suite and then doing redeploy on target production cluster. So I think that's part of the overloading term, then we may want to change this.
I mean, the dream is that if we get to these standard metadata, for Googlers here, it's like you develop protos, and those protos can now be represented and binded to your language of choice. So for example, we had a schema, you could take that schema, you could build a Python package for it, and then all of a sudden now you're able to instantiate, pick up this thing and instantiate a native object in your notebook that says, oh, this was the training run, and this is the model, and this is so on, and you can make all kinds of intelligent decisions around that. That's really powerful. Again, that's not tomorrow, but it's also not terribly hard, right? Once you have a proto, there are a whole bunch of standard ways to translate those into specific language bindings. Yeah. So we mentioned that earlier. KSonet was a choice. It was not a good choice. We're moving towards Kustomize as the new templating, which is native to Kubernetes. But, and I don't know if you heard what Jeremy said earlier, really what we're trying to do is abstract away or provide clean layers for the different things that are needing to be provisioned. And so I expect what you will see is both a packaging format for particular components that is made out of customized, and then you would have something like Helm or something like that that allowed to deploy many of those things together. Or something like if you're on Google Cloud, maybe it's Deployment Manager, a Deployment Manager template. If you're on Azure, you have Azure Resource Manager that then provisions Helm, that provisions using customized. So I think what you're going to see is as we clean up the layers, you're going to be breaking these apart. There will be syntactic sugar, as Jeremy said earlier, that tie these together for your platform of choice. But with the APIs and everything changing so rapidly right now, it'd be a little bit premature to start building higher layers. Okay. Any other questions? We are out of time, but I'm happy to sit here and keep answering.
So anyone wants to participate on the metadata management, the people that are not already on the list? Or?
Yeah.
So maybe we'll just gather outside.
Yeah, if you're interested in metadata, we'll just gather outside, but we'll keep answering questions until they forcibly remove us. Go ahead. What was your question? I don't think we've ever thought about an operator for expansion. Like basically, you would templatize and hand it to an operator in your cluster.
But I mean, you can easily configure the operator itself. So okay. So just the Helm deployment or operator is the case, just a unified way to deploy everything.
Yeah.
Well, and this approach seems to be working. And after all, it's probably something that makes right now KubeFlow somehow unusable for on-premise deployments, for instance. I mean, KFCTL, it works on your on-premise distribution, but just it's kind of it's an additional complexity. So
I hear you. I think that we would be open to the installation will be a mountain we will climb forever, like making installations simpler, more portable, and things like that. Writing an operator or other higher level structure to accomplish that, I think we are more than open to it. I think we have to solve the get rid of KSINet first, and then we would go from there. But I have absolutely no objection with using an operator.
I think the other problem is that many of the components have multiple lives. Like TensorFlow could also live without KubeFlow. So I think it has to be sort of componentized, that each component needs to take care of itself, and then you could install it, whether it's in the context of KubeFlow or there are some specific tools that are KubeFlow, like KubeFlow pipelines. But if you want to install Horwood or Seldon or Nucleo or any of those, they should have independent installation.
Yeah, but if you need to install Seldon, for instance, you can just you can change the logic of the operator itself, so it can handle all this. So it can use, I don't know, config map, for instance, to describe the deployment you want to.
I'm personally in favor of Helm chart for all of that, and for multiple packages, but.
So okay. Yeah,
metadata,
thank you.
if you're interested in metadata, we'll just go meet right outside here. Thank you all for coming.